So last time we had a look at LM Studio and we explored some small models. I found a really good model, which was the Qwen3 1.7 billion parameter model. And it was about 2 gigs in size, performed really well. But there was a really promising model in the form of that 0.6 billion parameter model. And that was tiny. It was less than 500 megabytes. So it fits very easily within the RAM that I have. And what I wanted to do today is to go over some techniques for working with smaller models and see if we can get that 0.6 billion parameter model to behave better. So let's take a look at that. Now, recap. We wanted to analyze some user feedback for insights. And we have this particularly gnarly example of some user feedback, which included this colloquialism about pigs might fly. So we wanted to see if we would avoid that. And it's jumping all over the place with lots of points and stuff. And we fashioned some perfect output with the help of AI. And these are 5 specific insights that I think is important to capture from this input. And ChatGPT was okay. It got more insights, but it was getting stuff that I didn't really want it to capture. The 1.7 billion parameter model also captured around the same number as ChatGPT. So while neither of them were particularly bad, they weren't close to perfect. I want to see how we can utilize some prompting techniques to modify 0.6 billion parameter model to get closer to this perfection. Here's the prompt that we used. We use a one shot, which means that we have one user input and one specific example output as an example. So if we take this again, we've got our 0.6 billion parameter model and we're pasting this into LM Studio and we do that. And I've got the tools open here. And the thing that I to pay attention to here is a temperature. And what the temperature is it's kind of like a randomness, how much randomness to introduce. So 0 will give the same result every time. Higher values will increase creativity and variance. So now, even if I update that to 1, it's always giving me 2 insights. So those 2 insights are good, but I wanted to capture more insights. And it's pretty consistent in that capturing of 2 insights. Now, I think the issue might be that I've given an example with 2 specific points as a benchmark. And I think the 0.6 billion parameter model is paying too much attention to the number of specific points that I want to capture. And for that reason, it's missing a lot of the other insights that are in here. And so what I might try to start off with is what's called a few shot example. So instead of just one example where I have 2 specific insights that have been found, I want to give another 2 examples where I have more insights found. So there's one with 4 and there's another one also with about 4 or 5 specific points found. So all I'm doing differently is I've got 2 more user input and output pairings as examples to use with this 0.6 billion parameter model. So let's copy that and let's create a new chat and let's try that out. And it's found 3 this time. Let's try again. 2. Let's try again. 3 insights. And this time 4 insights. But it got caught up in that colloquialism. So I want to test this a number of times. So let's test this 10 times. Now this is looking promising. There's the issue with the colloquialism that it's getting caught up with, but it's definitely capturing more insights. But it's still a little bit random. Sometimes it's capturing 4, which is good. It's actually quite close to what I'm looking for. Sometimes it's capturing only 3. So sometimes it's missing some insights. What can I do now to get even better with this? Now, bear with me a little bit. We're about to get a little bit technical, but don't worry, we're going to get through this. What we have here is a simple JavaScript function. A equals 5, B equals 10. Result of A plus B is 15. So if I run this, I get 15. All great. But imagine this code was much more complicated. And we had somewhere along the way +1 added to the value of B. So there's a lot of other code, and then B plus equals 1. And then when we run this, the result we get is 16. But we want a result of 15. So where is this going wrong? I want to introduce you to a concept of breakpoints. A breakpoint is a concept and technique in development where we can insert a pause or break in the running of some piece of code so that we are able to take a look around and view the state of the application at that given point in time. And how this works in practice is that we can insert a breakpoint at any point in time of the code. So imagine we were to enter a breakpoint here. So I'm just showing you this by adding debugger, and we were to run the code pauses as soon as it gets to the debugger, and we're able to evaluate what the values of the variables are. So at this point, A equals 5, B equals 10. So at that point in time, everything was working fine. But then if we add another debugger after this point and run it, we're able to see our variable B is equal to the value of 11 at this point. Now, why am I telling you all of this? Well, we can think of an LLM as a very complex piece of code. It's a black box. We prompt in, we get something out, and we have no idea what's going on inside. And we need to insert a breakpoint somehow. We don't have control over the code base of the LLM. But what we do have control over is the prompts that we use. And we can simulate breakpoints using simplified prompts. I'll explain what I mean. We've got our user input, which is here, and it's really messy. And perhaps we're asking too much from this little model, because not only are we asking it to find the insights, but we are also asking it to structure it like this. So let's try something. Copy that and paste it in here, and then let's take away no think, because I want to see what the reasoning steps are that this model goes through in order to determine what the output should be. So let's take a look. Yeah, as we suspected, first it needs to identify the specific points from the input, and then it says the user highlighted some issues, and so far it looks pretty promising in the things that it brings up in the thinking, in the reasoning. So now here's what we can do. We could split this into two prompts. The first prompt where I just get the LLM to focus on summarizing and focusing on the insights and not worry too much about the structure, maybe just return it as a list. And then the second part is where I take the output from the previous part and then I get it to structure it. But let's try part one. And let's apply no think to this as well. Delete. I'm not going to lie to you. It's not perfect. Let's try it again. Let's try it a few times. Still coming up with 2 insights. Let's increase this temperature a little bit and try again. 3 insights, 2 insights, 4 insights. Okay, so still not very consistent. But I've not given up on this yet, because if we look back at our structure that we wanted to find, we are asking it to find insights across a range of sentiments, positive, negative, and neutral. What if we were to make this even easier? What if we inserted another breakpoint where we said, look, just give me the insights, but just give me the negative insights. And here's my prompt that I've pre-prepared for that. So all I'm doing is I'm getting it to list the negative insights first. Let's delete, and I've got the 0.6b model loaded here, and let's try it. And cool, this is much better. 5, and it's found all of the right insights. Let's test this again. And again, it's found 7, but there's pretty decent insights as well. So it's on par with ChatGPT, and it's found 8 this time, and it's not picking up on that colloquialism, which is good. Let's test it a few more times. Cool. Now this seems to be working pretty decent. I've got the temperature set at 0.31. I could play around with different temperature settings if I wanted to, but at this point I could take this insight and then apply it to another prompt where I get it to structure the output. What did I tell you? Promise, right? Those chat GPT shitheads are the size of a planet. This thing is the size of a pea, and I'm able to get the same performance out of it. I mean, albeit with 3 prompts instead of 1, but still, it works a lot faster. The job's not finished yet. I need to test this a lot more, and I need some way to automate it. But having a look at the interaction pattern, here's what it looks like. All right, so here's our final interaction pattern. And yes, I'm trying to make interaction patterns a thing. I've written an article about it if you want to find out more. But anyway, we have our user feedback, and that's our input. Then we prompt for negative insights. And then, optionally, we can prompt for positive insights. And then after that, we structure the output before we have our final output. And using this interaction pattern, we're able to get the best out of our small model. Okay, so I hope you found this useful, and I hope it spurs you on to try out these small models and try out these techniques to see if we can get the most out of them. Until later.